So, good evening to all. Is the audio and video clear for everyone? Please say. Thank you. Right. So, today we are going to discuss about real analysis. This session is an introductory session. So, first of all, I want to invite everyone to ask their questions. Then I am going to start with my part. So, please go ahead. So, what are the doubts or questions we have? You please go and feel free to ask. So if you have no questions at all, then I start with our regular frequently answered questions. Right? So one question is about difficulty level. And for the others, any other queries please to anyone? Fine. So here I want to cover the following. So I want to mention what is the maximum time required to cover the portion of the syllabi, and what are the prerequisites for understanding the content for this. You can call it as the prior knowledge. And another one, what are the textbooks we need to follow, and as usual we will give the syllabus for this part. And any other queries please to anyone apart from this. You can ask for the weightage, and you can go for the preparation time, so which you can call upon the difficulty level, and the key areas to concentrate in the syllabi. So number of classes, I am just talking about the time. Fine. So any more queries please apart from these things to anyone? So other topics related to this one, I can say mostly it is independent, but one thing you can correlate with calculus. Some portions not in detail. You can detail with calculus. That is one thing you can call. So which comes under paper 1 of UPSC syllabi. Any other queries please to anyone? Fine. So I will say that the maximum time you can go for 40 hours so that we can finish the whole syllabi. So you can get all the concepts and the strategies to problem solving techniques, that I can say for the whole syllabi at the most. And the prerequisites, it is the independent topic. So you can say that a little knowledge of calculus is enough, not in detail. If you know what is meant by a continuous function and a limit, that is enough. So not the deep understanding of the calculus is required here. Here you are learning a different way of the approach. And I will mention the list of textbooks as well as the syllabi. And weightage, usually the minimum weightage is 50, at the most 70 you will get. And preparation, I can say, once you start the whole syllabus preparation, and then initial reading of 2 hours per day will be sufficient if you have the good idea. And after this, we go with previous year questions. The only difficulty for this topic is, compared to the previous questions, at the most you are going to answer 95% of questions, not 100%. That is the one setback for this portion you can call. Sometimes if the difficulty is more, at the most you can answer 80% of questions. And one good advantage of this part is nothing but majority of the questions will come from the standard textbooks. Provided the example based. That is one good advantage for this topic. Right? So while listing out the syllabus, I will give the key areas where you need to concentrate in that syllabus. And this portion will come under paper 2. Right? So any other queries, please, to anyone? Please say. The thing is, there are some areas where questions are in a different way. So unless you have solved the standard textbooks completely, you cannot attempt a 100% thing. That's the problem, because it takes much time in preparation. For some areas, it takes much time. But if you select the key areas, so always we go with the majority. So minimum assurance is 90% is the minimum assurance. That you can say, if the weightage is 70, definitely you will get 50. That we can say. Because some areas are unpredictable, right? Because some questions will be based on theoretical concepts. So if you know all the theoretical results, then you are able to do any kind of problem based on this. That's why I have mentioned the difficulty level in such a way. Right? Any queries, please, to anyone? Please tell if any other queries you have. Right? So, can I read the syllabus first? I will give the list of books also. Right? So this was the syllabus. So real number system as an ordered field with least upper bound property sequences limit of a sequence Cauchy's sequence, completeness of real line, series and its convergence, absolute and conditional convergence, rearrangement of series, continuity, uniform continuity, properties of functions, Riemann integral, improper integrals, fundamental theorem, then you have the case of uniform convergence, is it visible if I write on the top? Right. So please take a note of these things, then I will write the syllabus of the remaining part. If everyone is finished with this syllabus, then I write the last part of the syllabi. I think I can write here. Uniform convergence, continuity, differentiability, comma integrability. And then we have maxima and minima. So this was the syllabi. Right? So if you have a close look at the syllabi, it seems to be very vast, but the very first part of the syllabi is nothing but the properties of real numbers which you come across at your +2 level. However, if you have the knowledge of these things or not, that doesn't matter, because the actual syllabus portion will start from this part. Sequences, limit of sequence, Cauchy sequence, etc. So with regard to the examination point of view, we can say over the years, majority of the questions are framed on series and its convergence, absolute and conditional convergence. So while going through the preparation, we have to go a deep understanding over these concepts. Then you have majority of the questions framed on Riemann integral and improper integrals, and occasionally uniform continuity. And other major area is uniform convergence. So over the years, these are the key areas in the whole syllabi of reanalysis where we need to concentrate. Okay. In other words, we can say that in the whole syllabi, whatever the question is framed on this part, you can give guarantee of one or two questions over the underlined part that we need to understand. The things which are highlighted here, we can get at least one or two questions over this part. Okay. So under the compulsory section, you have the minimum weightage of 10 marks. If you go to the other questions like question number 2, 3, 4, etc., the minimum weightage you are going to get it as minimum 17 marks to 20 marks for a particular question. That was the usual weightage, or the least will be 15 marks. Is that fine? Right. So if you have noted this, can I erase the syllabus part? Then I am going to list out the books where you need to concentrate. Okay. I am going to erase the syllabus. Can I? Fine. Now coming to the books which we need to follow. One is Real Analysis by Shanti Narayan and Rai Singhania. One book is Real Analysis by Golden Publishers, and one book, Real Analysis, a course of mathematical analysis by S.C. Arora. And you can have the part with Real Analysis by C.H. Malik. Again, you have Real Analysis by Krishna series. So these are some of the books which we are going to study. At the most, you can take one book for your preparation. If you have a thorough understanding or your reading and the class sessions, then straight away you can go with solving previous year questions. That's the whole idea of preparation that I can say. Okay. And mathematical analysis by Shanti Narayan is also there, which is the best book, easy to understand. I can say the easy way to understand by Golden Publishers. And for the majority of the cases, people will study Real Analysis by Rai Singhania, so which we usually give preference. Because the advantage of these books is many of the questions are framed as the example problems from these textbooks. Over the years, you can observe. Okay, is that clear? Right. Any other queries, please, to anyone? Yes or no? So if you are done with your queries, then I will start the class session. So can I proceed? Thank you. So first of all, I am going to start with the topic sequences. Now, I am going to convey one thing before the start of the concepts. The whole approach of free analysis is simply based on whatever the topic you wish to start, you will have some basic definitions over the chapter. That is one. And there are some problems solvable on definitions. Then, as and when you are learning different types of problems, our approach is for each chapter, you will learn some standard results. We can call them as theorems. So what happens? The theoretical solutions of theorems generally won't be asked in the exam. Our concentration is mainly on problem solving techniques. So using the statements of the results and the techniques given by those theorems, you are going to solve the problems. The only difficulty level for each chapter is what theorem or result you are going to use to solve a particular problem. That is the only difficulty. Apart from this, all the definitions and problem solving techniques will be very clear for everyone. As in when your question is given to you, what kind of theorem or result you are going to use at that moment to solve that kind of particular problem. That is the only difficulty. So it will be achieved by thorough practice. That's it. So in the beginning, for the first 1 or 2 chapters, it looks like a little dry subject. But as and when the sessions are passed by, you will feel comfortable with this topic. Because the problem is, if majority of the students has a BTech background, etc., they won't come across with this type of content earlier. That is the main problem. Because there you have a little concept, based on that you have a derivation over a particular formula, and by applying the formula in different cases, you are going to get the results and the problem gets solved. Here it is somewhat little different. Initially you are learning different concepts, then you are applying the concepts to solve different varieties of the problems. That is the main difference between the earlier concepts what we have learned and this one. Okay, is that understandable for everyone? Please tell. Right? And may I know, so did any one of you have prior knowledge over these concepts of real analysis, or you are learning for the first time? So that I can mold my sessions based on your feedback. Fine. So this is an introductory session. Later from Monday onwards, we will start our regular discussion on this real analysis, right? So let us start with the part sequences. If you think of sequence, it is nothing but a function defined from natural numbers to the real numbers. That was the definition of a sequence. So sequence is nothing but a function which is defined from natural numbers to the real numbers. So if you write like that, I have defined f from n to r by f of n is equal to 1 by n square. It is nothing but a sequence. So if you talk of, if you want to write a sequence, it is nothing but you are simply writing the images under this function. So substituting n is equal to 1, 2, 3, 4, so on, the sequence which you are going to write it as 1 by 2 square, so this is 4, 1 by 3 square 9, 1 by 4 square 16, and so on. This is the sequence. Is the definition clear? Right. So it is nothing but you are simply writing the images under the function which you have defined. You can define the function in different ways, like f of 1 is equal to minus 1 whole power n, f of n is equal to minus 1 whole power n by n, f of n is equal to 1 by n plus minus 1 whole power n. In different ways you are going to define, or you can write f of n is equal to 3n plus 2 by 5n plus 1. So all these functions are nothing but sequences. Now, how do we denote a sequence? So usually if you say that f is the function, the symbolic notation is fn. We write fn with these braces less than and greater than, or you can write fn from n is equal to 1 to infinity. So these are different notations available to denote a sequence. And usually if I write f1, it means that in the sequence I am taking the first term. If I write f2, it indicates term number 2 in the sequence. So if the function is x, we write the sequence as xn, or if the sequence is given by sn, we will write sn. So s1, s2, s3 indicates term 1, term 2, term 3 of the sequence which you have written, the images which you have written. So if I write in this what is f3, so term 1, term 2, term 3, so this is nothing but f3. Okay. So from natural numbers to real numbers, we are defining any kind of function that is user defined. So if you define a function s from n to r by s of n is equal to 1 by n square plus n, this is a sequence. So here the images defined under this function is nothing but the sequence that we need to understand. Okay, right. So how you are going to get the elements in the sequence? By simply putting the natural numbers 1, 2, 3, 4 in this expression, you will get all the elements in the sequence. So how do we represent a sequence? One thing is listing out all the elements like this. That is one kind of representation. Another one is by writing the nth term like this, because f3 stands for third term, fn stands for nth term. So the terms of the sequence which satisfy a property, that kind of representation we follow to denote a sequence. Another one is a sequence will be defined by means of a recursive formula. So let me say I am going to define like this. Fn plus 2 is equal to Fn plus 1 plus 3 into Fn. So for all n greater than or equal to 3, right? So what happens if I know what is F1 and F2? Using this formula, I am going to write F3, F4, F5, etc., etc. For convenience, let us say F1 is equal to 1 and F2 is equal to 2. Then what will be F3 using this result? So F3 is nothing but F1 plus 2. Am I correct? Like n plus 2, I have written like this. So it is nothing but F2 plus 3 F1. Accepted? Using the recursive formula what I have mentioned. So substituting the values there, what is the thing you are getting? F2 means 2 plus 3 into 1. So the value is 5. Right. So if you want to write F4, you can write F2 plus 2. It is of the form n plus 2. It is nothing but F3 plus 3 into F2. And by substituting these values, you are going to get the value of F4. Is it clear? Right. So the regular representations of a sequence is like this. One is writing all the elements, nothing but all the images in a set. Another one, simply writing the nth term like this. Another one, if the first two or one term is given, by means of a formula, you are writing the all terms of the sequence. This is one usual notation. And let me give one thing, that in the first chapter sequences, you have more number of definitions because it is the base for the next chapter, which is infinite series. Later on, the definitions will be very less for each chapter. At the most, you are learning 3 to 4 definitions. But in the first one, you have a lot of definitions to learn because you are starting afresh. Okay. So is this definition part clear to everyone? Yes or no? Right. N should be greater than, you can take n greater than or equal to 2 also for some cases. I have just taken an example to define a formula. You have a lot of recursive formulas to define a sequence. While going with the problems, your doubt will be clarified, right? N should be greater than 3 is not mandatory. Let me say, I have defined a sequence like this. S1 is equal to 2 and Sn plus 1 is equal to 2 into Sn for all n greater than or equal to 2. Let me say here. If I have written like this, how you are going to take? If you take n is equal to 1, then using here S2 is equal to 2 into S1. If you take n is equal to 2, S3 is equal to 2 into S2, like that you are defining. Is this understandable for writing the sequence? So there are different ways in defining a sequence, right? You have so many recursive formulas available. Fine. Now, I just want to take one example. Just hold on a moment. so that I will take some examples for your understanding. So just take that the sequence is defined by Sn is equal to -1 whole power n. Now, can you give me the values in that sequence? So if you put n is equal to 1, S1 is nothing but -1. Accepted? Because the elements in the sequence will be written as for n is equal to 1, 2, 3, 4, so on. It will come like this. This is the sequence which you got. Now, if you talk of the range of a sequence, the range is nothing but all distinct elements or all distinct images. Now, what is the range of that sequence then? 2, because the range is simply -1 comma 1. Right. If you take the simple example that Sn is equal to 1 by n, the function of the sequence, then how the sequence will be defined? 1, 1 by 2, 1 by 3, so on. Now you can observe that all the elements in that images are different. So what is the range of this sequence? Only n. Is it a finite sequence, can we say? You will get so many elements there, right? So what is n stands for? Because you are taking n belongs to n. I think you got my concept right now. Yes or no? If we have defined Sn is equal to 1 by 3 power n. Now how it is going to become? 1 by 3, 1 by 3 square, 1 by 3 cube, so on. Isn't it? Now, what is the range of the sequence here? Is this infinite or not? Right. So, by observing the range of the sequence, we are saying that a sequence is finite or infinite. So, if you say that there are finite number of images for the function, we call it as a finite sequence. If there are infinite number of images, then we call it as an infinite sequence. Now, after noting that whether it is a finite sequence or infinite sequence, by observing the values in that sequence, we will go for some definitions. We call them as bounds. Right? There are some definitions that lower bound, upper bound, least upper bound, greatest lower bound. Right? These are some definitions. So please take a note of these things. So earlier you have so many definitions in the beginning, then you are going to get the content of the chapter. suppose you have a sequence Sn, say S1, S2, S3, so on. Now, if you find a real number k such that every element in the sequence is bigger than this, then we say that k is a lower bound. So the very word lower indicates that the number which you are specifying is less than or equal to every element of the sequence. Is that clear? Yes or no? So if you write a small sequence, let me say, so what is the lower bound? Usually when I talk of bounds, they are finite in number usually, not of infinite values. That's why I have mentioned that there is a real number k. If you are saying that there is a number, it is finite. So if you write a sequence like f of n is equal to n square, this is the sequence, right? 1, 4, 9, 16, etc. Now what is the smallest value in that sequence? 1. So can we say that 1 less than or equal to Sn for all n in this sequence? Accepted? So we say that 1 is the lower bound for this sequence. Not only this, you can say 0, -1, -2, so on. All these values are also lower bounds. We can observe that. Clear or not clear? Right. So if you take all these values, among all the lower bounds, 1 is the bigger one, isn't it? So we call it as the greatest lower bound. So if you know a set of lower bounds in which if you pick up a big number, we are calling it as the greatest lower bound. The other name is infimum. So if you draw a small picture, let me say this is my sequence. So all the values before it are nothing but the lower bounds, among which this value is bigger in all the lower bounds. So this one I am calling it as the greatest lower bound or infimum. Clear? Right. So can you say that what is the last element or maximum element for this sequence? So we don't know actually. We cannot say that infinite is a number. We don't know actually the last element of the sequence, right? So in this case, we say that we don't know the upper bound of the sequence. We know the lower bound. We don't know about the upper bound of the sequence. So we say that the sequence is bounded below, not bounded above. Is the technical term clear? It is bounded below, not bounded above, because we don't know the upper value of that. Right. Similarly, let us take another one example. Say f of n is equal to 1 by n. If you talk that so in this sequence, what is the maximum element? 1. So if we have written a sequence here, if you say that this is my sequence, you know the big value of it. Because whatever the element you take here, this is less than or equal to 1. Accepted? So we say that 1 is upper bound of the sequence. Not only 1, 2, 3, 4, 5, 6, all these are upper bounds of the sequence, among which 1 is the smallest upper bound. Accepted? Right. So we say that least upper bound is 1 because it is an upper bound. In all the upper bounds, it is the smallest one. So it has another name. We call it as supremum. So least upper bound is nothing but, yes, 2, 3, 4, 5, 6 are not in the set. It doesn't mean that upper bound must belong to the set. That is not the criteria. The definition is simply given that Sn less than or equal to k for all n. That's all. If you know a real number that every element of the sequence is less than or equal to that number, we call it as an upper bound. So least upper bounds, greatest lower bounds, etc. sometimes they belong to the set, sometimes they don't belong to the set. Right? It's a different issue. So least upper bound has another name. We call it as supremum. Greatest lower bound has another name. It is infimum. Is this clear to all? Right. So if you know that a sequence has lower bound as well as upper bound, both will exist. We call it as a bounded sequence. So what is meant by a bounded sequence? So how can you say that 0 is the lower bound in this sequence? Because you have applied limit n tends to infinity 1 by n, the result is tending to 0, isn't it? Yes or no? So that you have mentioned that the lower bound is 0. Am I correct in your sense? Fine. So we come to that part, the concept of limit later. Before that, if you specifically know that this is the number in this sequence, which is the upper bound, which is the lower bound, then we say that the sequence is a bounded sequence. If only one bound is existed, we call it as an unbounded sequence. If both are present, then only we call it as a bounded sequence. Now, if you take the previous example, what I have mentioned, -1 whole power n, as you have written, this is the sequence. Is it a bounded sequence or not? Because it has the smallest element -1 and the largest element 1. In other words, you know what is the lower value of this sequence and upper value of the sequence, isn't it? So we call that it is a bounded sequence. Is this clear for everyone? Right? Now, let us take a small modification here. If you take that -1 whole power n by n. So let us write this, what it is going to be. Am I correct in writing the terms? Now tell me, what will be the smallest of this and what will be the biggest of this? -1 is the biggest element, smallest element, right? So 1 by 2 is the biggest one. So can we say that it is a bounded sequence? Right. So if specifically say that this is the smallest value for the terms and this is the biggest value for the terms, then we call it as a bounded sequence. I hope that this example gives the idea or the boundedness. Right. So now concluding the discussion here, I want to define what is meant by the limit of a sequence. If the sequence 1 by n is bounded, we say that the sequence 1 by n has limit. So as and when a sequence has limit, we call it as a convergent sequence, and every convergent sequence is bounded. So the answer is yes, it is a bounded sequence. Okay. Right. Now, coming to the definition of limit of a sequence. Suppose if you write so what does it mean as per your definition of calculus? What can we understand if you draw a graph or a picture for it, or the mathematical definition of this limit? So do you have any idea of this? Say, anyone? Or you have totally forgotten? All right. So apart from your perception, here we define that at x is equal to a, f of x is almost equal to L, but not exactly L. The value of limit while approaching towards x is equal to a from either side is L. That's a good idea. So one opinion is this: not exactly L means you say that if you apply limit extends to a, f of x will not be equal to L always, or sometimes it will be equal to L. Right. Now, let me draw a thing that how do we define the limit of a sequence here? The mathematical definition is given by, if you have a sequence Sn, we say that Sn has limit L, where L is a real number, usually positive. For epsilon greater than 0, there exists m belongs to z plus such that modulus of Sn minus L is less than epsilon for all n greater than or equal to m. So this was the definition of limit of a sequence. So here you need to understand that epsilon is a small arbitrary real number. You can take it as 0.1, 0.5, 1, 0.6, 0.001 as per your choice. So this definition gives that if we have a sequence L, you can write that first term S1, second term S2, third term S3, so on, Sm minus 1, Sm, etc. You have the terms in the sequence. First term, second term, third term, so on. So since you have the real numbers, you say L is the limit of the sequence means first m minus 1 terms of the sequence, we don't know about them, but from term number m onwards, all the elements in the sequence will come within a short gap for L. That was the definition of limit of a sequence. So if you write a sequence Sn, The first m minus 1 terms, we don't know about them, but from mth term onwards, all the terms in the sequence will be in and around L. So if I say L is equal to 5, epsilon is equal to 0.1. So whatever the term value calculate, Sm, Sm plus 1, Sm plus 2, Sm plus 3, all these values are becoming equal to 5. They are coming in the span of these numbers. They are moving hither and thither of 5. Is this definition clear? So as you call right hand limit, left hand limit earlier. So this is the mathematical meaning and the mathematical definition we will give in this sequence chapter. So any queries to anyone? So here we need to understand that from term number m onwards, all the values in the sequence are becoming equal to L, and majority of the times they are equal to L. And if they are not equal to L, they are with a small gap in and around L. So they will be between L minus epsilon to L plus epsilon. So if I take that, epsilon is equal to 1 by 2, that is 0.5. All the terms in the sequence will be between 4.5 to 5.5 in this thing. So 4.5, 4.6, 4.95, 5.1, 5.2, the terms will be like this in that sequence. And we say that the limit is 5 because they are in and around 5. Is this acceptable to all? The concept of a limit? Right. So as and when a sequence has a limit, we say that it is a convergent sequence. If we say that Sn is a sequence and it has the limit L, we say that Sn is a convergent sequence. And symbolically we write that Sn tends to L, or limit n tends to infinity, Sn is equal to L. This we usually write. Fine. Any more clarity you require over this definition to anyone? Okay. Now, one question we always have is, what is this epsilon and what is this m? So we can say that epsilon is user defined. It is our real life choice. And m indicates the term number in the sequence. It means that for a given epsilon, m varies. If you take epsilon is equal to 0.1, m is different. If you take epsilon is equal to 1 by 2, m will be different. So initial values, that means the first m minus 1 terms are out of L. They are nowhere concerned to L. They are here. From this onwards, every term will be in this bound. That's why I have mentioned the first m minus 1 terms. Let me say, if I say that Sn is equal to L, let me say Sn is equal to 5 for all n greater than or equal to 100. It means that in that sequence Sn, from first term to 99 term, all are different values. We don't know about that. We are not going to comment anything on them. From term number 100 onwards, S100, S101, S102, all these values are becoming equal to 5. That was the definition of the limit. Fine. That is the significance of n greater than or equal to m. Is it clear to all? Right. So if I have asked that, I got a sequence Sn and I have given a number L, and you need to verify whether Sn converges to L or not using this definition. How you are going to say? Yes, as and when limit exists, it is a convergent sequence. A sequence which has limit, we say that it is a convergent sequence. Which do not have a limit, we call it as a divergent sequence. It is non-convergent. In other words, you are able to say that all the terms in the sequence are becoming equal to a finite number. That sequence is called as convergent sequence. The limit is existed. Okay. Is it clear to all? The question I have asked. If I have a sequence with me and I have asked you that this is the real number I am giving to you, so you please check whether this sequence converges to L or not. So from this definition point of view, as the definition says that from this term onwards, all the values are becoming equal to L. So you have to say that if I have taken epsilon is equal to 1, from this term number onwards, all the values in the sequence are becoming equal to L. If I take epsilon is equal to 0.5, I have to say that from this term number onwards, all the values in the sequence are becoming equal to L, just like that. So this is the definition check. Are you getting the concept? Yes or no? So initially you need to be a little patient because the subject is totally different from your perception earlier. Because I know that you didn't come across this type of strategy earlier. So later on the sessions you will get interested over this. Fine. Yes, a sequence can be oscillatory too. Because earlier you have said that -1, 1, it is neither tending to a fixed number. Exactly, your approach is right. We are going to find the value of n, after which it becomes L. That's all. Right. So if I have taken a problem for you, then you will have the idea over this concept. Can I? Right. So let me take one small problem here. So prove that two n by n plus 3 converges to 2. Take epsilon is equal to 1 by 5. Okay. Is it clear? The question. So what is the sequence here? 2n by n plus 3. And what is the limit? 2. And epsilon is equal to 1 by 5. So if you look at the definition of limit, modulus of Sn minus L is less than epsilon for all n greater than or equal to m. So you have to say that modulus of 2n by n plus 3 minus 2 is less than 1 by 5. So what is n? Is this context clear now? To all. If you have any queries right now, you can ask. Please tell if you have any other queries with you. Is this clear? Right. Now, we are going to simplify this expression. So if you go for the LCM, n plus 3, what will be the numerator? Yeah. Let us take that this is my sequence and give the definition one more time. So this is my sequence. If I say that the limit is L, so this is x-axis, the number line, this is y-axis, so this is the line L. Accepted? Now, if I specify the term number m in the sequence, say this is m, it means that from this term onwards, all the values in the sequence are within L, in and around of L. So, if you take that this is L minus epsilon, this is L plus epsilon, so all the values in the sequence will be here only. So before this, the other terms S1, S2, S3 will be here. Is that clear now? The first m minus 1 terms, we don't know about them. From this onwards, all the values will be in this narrow gap in and around L. Okay? I think it clarifies your doubt. Fine. And one of our friends simplified the expression that they have mentioned. This implies six by n plus 3 is less than 1 by 5. Simplifying this, n plus 3 is greater than 30, implies n is greater than 27. Accepted all? So it means that if you write S1, S2, S3, the terms in the sequence, term number n which is greater than 27. So term number usually a positive integer. So what happens from S28 onwards, all the terms in the sequence are becoming equal to 2 with a small gap of 1 by 5. Is that fine now? The definition? Yeah. So can I take one more example over this so that I will conclude the definition part, which gives a clear idea for you. Can I? Right? So I have defined xn is equal to 3n minus 1 by 4n plus 5, and I am going to prove that it converges to 3 by 5, converges to 3 by 4, let me say. Show that. Please take a note of the problem. Sorry. So the main difference between the previous problem and this one is nothing but earlier epsilon is defined. Here there is no value for epsilon. Accepted? So here epsilon is user defined. You can take as your choice. So simply we say that let epsilon greater than 0, and if you apply the definition, modulus of 3n minus 1 by 4n plus 5 minus 3 by 4 is less than epsilon. And you are going to simplify the expression there. So if you go for LCM, it will be around 19 by 4n plus 5 into 4 is less than epsilon. Could you check on that in the numerator? say, right? So this implies that 1 by 4n plus 5 is less than 4 epsilon by 19, implies 4n plus 5 is greater than 19 by 4 epsilon. Say. So this implies that 4n is greater than 19 by 4 epsilon minus 5. This implies n is greater than some value here. I can say, right? Are you getting the thing? So what can we say about this thing? It is a real number. Accepted? So if we talk of term number, we say that take m is equal to integer part of above value. So whatever the number is there here, the real number, you take the integer part of it. Let me say, suppose this value is 92.5. What is the integer part of it? 92. Because you are excluding the fractional part, you are taking the only integer part. So from term number, since n is greater than this value, so from term number 93 onwards, you will get the values in the sequence. Accepted? Right. So the concept here is, if you take epsilon is equal to 1, this will be something different. If you take epsilon is equal to 1 by 2, it is different. If you take epsilon is equal to 1 by 3, it is different. So always we need to understand one thing, that the integer value m, nothing but the term number in the sequence what you are finding here is dependent on epsilon. If epsilon varies, the term number varies. This part must be known to everyone, right? Yeah. So the real question arises here is, since you know the definition, if I have a real number and I have a sequence, using this definition criteria, I am going to verify whether the sequence converges to the real number or not. Now suppose what happens, is this always possible to apply this kind of definition for every real number and for every sequence? It is a tedious procedure, right? Because always you have a sequence, you need to simplify. You have to simplify the expressions to get n. It's a different perception. So can we take limit epsilon tends to 0 and find the limit? Limit finding is always possible. Let me say, if you take the previous case, earlier you have proved that this converges to 2. Now let me say, if you take limit n tends to infinity 2n by n plus 3, what is the value? Is this 2? Yes or no? Please tell me. Is this equivalent to 2? Right? So this part of calculus you have known earlier in the limits. So that's why we are not talking that part again. Taking limits application we are not taking. So here we are going somewhat little different. So there you have solved so many concepts like, let me say, limit x tends to a, if you have f into g, it is equal to limit x tends to a into f into limit x tends to a into g. Accepts this formula for plus, addition, subtraction, division, etc., etc. What is the theory behind these formulas? that we are actually thinking now. Because this kind of problems in calculus we have done so many at +2 level. So we are not bothering about the limit calculation. So what it actually gives to you, that is one thing. Sometimes it is not possible to say or not possible to apply by using this technique. What is the limit of the sequence? You don't know how to calculate the limit. The concepts of L'Hospital rule, etc., etc. Some cases won't work here. But you should know, I have a sequence with me. I should know whether it converges or not. I don't know about the limit part. I just want to know whether it converges or not. That is my main perspective. Okay. That's why we have some theory behind this. So that if I have a sequence with me, by checking what type of conditions, I am able to say that the sequence has a limit. Please understand, here I am not calculating the limit of the sequence. I am just thinking whether it has the possibility of tending to a finite value or not. That's it. So if you talk of a real life application, suppose you have taken the case of a tsunami. The tsunami is going to attack a specific area. You have a pre-recorded data. The case of tsunami is over that area. You have tabulated the data in the form of a function. So by simply checking the nature of the function, whether it is tending to a finite value or not, so that you are going to say the effect of the tsunami over that particular place. That you can take one real life example. Fine. So just knowing the convergence, you can say that whether it tends to a finite value or not. That is the case. You are not interested to calculate the limit of the sequence. You are interested to know the nature of the sequence, whether it is tending to a finite one or diverging to it. That's it. There is the whole idea behind this. Okay. I think the concept of sequences is clear for everyone. I hope so. So since I have started afresh, I just want to conclude the session by simply giving a definition, and we will meet on Monday with regard to reanalysis. The concept is so on Monday I am going to take some problems on this monotone sequence concept. What is meant by a monotone sequence? I know that you know what is meant by a monotone function. I hope so. So we have a class on Saturday with regard to the previous concept of linear programming. There we are going to concluding by taking some of the doubts. So and we are starting afresh on Monday. That's the case. Because it is an introductory class. So to give the nectar of reanalysis, I have taken this. Fine. So let us take a sequence in which all the terms are either increasing or decreasing. So if all the terms in the sequence are increasing or all the terms in the sequence are decreasing, that type of sequence we call it as a monotone sequence. I hope that you have known about the monotone function. It is just like monotone sequence. Is this definition familiar to you? Right. So if you take a simple example, say 1, 1 by 2, 1 by 3, so on. This is a monotone sequence where the values are coming down, decreasing. Accepted? Right. So as and when you take a decreasing sequence, it always will have the highest element, the upper bound, isn't it? So the upper bound for this sequence is 1. So can you be able to say the lower bound? Don't calculate the limit. So if you are able to say about the lower bound, then we say that it is a bounded sequence. Accepted? Right. So if you take an example like 1, 4, 9, 16, where the sequence is defined by f of n is equal to n square. It is a monotone sequence where the values are increasing, isn't it? Yes or no? So if you take an increasing sequence, always it has the smallest value 1. Accepted? We cannot comment on the upper value, but you know that it has always a bounded lower one. It is bounded below. We don't know about the upper bound, isn't it? So here I want to say that a monotone sequence is nothing but a sequence which is either increasing or decreasing. A decreasing sequence always will have the upper bound. It is bounded above. An increasing sequence will always have the lower bound. It is bounded below. That's it. So based on this concept, we are going to solve some kind of problems on Monday. So here I want to wind up my sessions. You can comment anything if you have. So any more queries, please, so far to anyone? If you have none, let us wind up now. So can we wind up our session now? Thank you. So we will meet on Monday for this part.